This is take 4 of the voltage divider formula video in case we need it later on. Yeah, I tried freestyling a little bit, but like not rehearsing and all, but it didn't come out quite right. So this is take 4, and let's get to it. Okay, so the ESP3288D1 Arduino Uno clone and the L293D motor driver shield. Okay, so the GPIO pins shouldn't exceed 3.3 volts or they might get burned. I was planning on using the ESP32 dev kit. However, I found an Arduino clone I had laying around and that should work. It is Wi-Fi capable, which is good for what I have planned. Now, yeah, you might notice that uh, it uses DC motors, and that is and the reason why is because they pack more torque than say a servo. Uh, Although a servo can pack more torque, but it'd be a bigger motor. So yeah, the plan is to use DC motors. So yeah, we were using the GPI opens of the dev kit. We might have needed this, but however, we might not need this. But just in case, the 18650 lithium batteries rated at 3.7 volts, but my voltmeter reads 4 volts. The MA can vary. Mine are 9900 MA. Now, MA is how long the batteries last. 3.7 volts are the volts. MA is the current per hour. And 3.7 volts is the energy. Uh, well, the power is 3 point is volts and current. So yeah, I'm not gonna go over that, but anyways, the voltage divider circuit. It is important that the first cable goes in between the resistors, or you'll get a different value. It is also important that the first resistor should be the lower value, or you'll also get a different value. Now, you might need more than two resistors, and the reason why is because in order to get the value, you might not have the exact value for the first resistor. So you can connect them in series. So you can have, say, for the first resistor, you can have, say, 3, 2, or 4. I don't know. However resistors you need, as long as they add up to the value that is needed, it is okay. Moving on. Okay, so yeah, I paused the video a little bit. I made a few typos. Anyways, the step-by-step solution. 3.3 volts equals 4 volts times 1,000 ohms, which is a random value we picked for the first resistor. I mean the for the resistor, divided by 1,000 ohms plus x. So then we multiply both sides by 1,000 plus x, and then we get 3,300 plus 3.3x equals 4,000, which we subtract 3,300 from 4,000, and then we get 3.3x equals 700 divided by 700 divided we divide 700 by 3.3 and we get 212.12. Now this is we've all been to school. Well, a lot of us have been to school, And yeah, it's been a while, and yeah, I was struggling a little bit because I kept multiplying four times the whole thing instead of just the first part. But anyways, yeah, the answer is 212.12. Do not use ChatGPT 4.0 Mini or Gemini to verify the math. Use Wolfram Alpha instead. Vanilla code might work too. Not sure if the bigger ChatGPT models might be better because somebody pointed out that the bigger ChatGPT model gets it right. But as we can see, I asked it what if the initial voltage was 4 volts and the first resistor is 1 kilo ohms, uh, and the output. And the output is 3.7 volts. Yeah, it gave us a completely different answer. Wolfram Alpha got it right. So if you want to verify the math, just in case, I recommend you use Wolfram Alpha, not ChatGPT. But although if you put it in formula form, ChatGPT might get it right too. But I'm gonna start fact checking these AIs because like in my last video I said that the center of mass of corporate robots was in the middle. Not quite sure if that's correct now. I do not want to spread falsehoods. Okay, so Tinkercad. Tinkercad does not allow us to use a voltage of 4 volts or 3.7 volts because it uses alkaline batteries instead of lithium batteries. The alkaline batteries are 1.5 volts. There are alkaline batteries that are higher than 1.5 volts, but um, yeah, Tinkercad also has 3 volts button cell batteries, but anyways, yeah, we'll be using 3 double A alkaline batteries, which should give us 4.5 volts, 1.5 times 3, and we're gonna take it down to 3.3 volts, which means the second resistor value should be 363.64 ohms, around that. I'll skip testing it outside of Tinkercad since we might not be using it for now. I have one more presentation video prepared up next before I try making the small scale testing robot. I do not want to make any promises on the deadline, although ideally the robot after the second presentation the robot would be done after 1 month or so, but you know uh, sneak peek for the next presentation. So here we have some motors, some gears. That is the shield. That is a box where the shield might go. I don't know. It's a work in progress. I've decided to stick with FreeCAD for now. I wasn't thrilled about Onshape's policy of making the 3D models public. I want to be a little selective about what I share. And yeah, there's Fusion 360 as well. I do have a Windows drive. I have 3 drives. I have 1 terabyte Windows, 500 gigabytes Windows, and 1 terabyte Linux. And it is not because I am necessarily a free software advocate, but because I am a little bit paranoid. Because I tried using ipconfig on Windows and check disk, and they were missing. That made me a little bit nervous. So yeah, just in case. Anyways, moving on. Um, let's get down to it. And I do say we and I interchangeably. Doesn't mean that there has been much in the way of collaboration. Oh, Yeah, need to catch some breath. This is gonna be tough. Okay, yeah, doing Tinkercad on real time is gonna be a little bit rough. But anyways, yeah, I know. I noticed in indie games as well that getting collaboration going, it is rough. Yeah, and outside of paying someone or something, then if you pay someone, then the collaboration is easy. Otherwise, it is rough to get it going. But yeah, yeah. Okay. Anyways, moving on. Uh, let's start by connecting the negative charge of the batteries to the negative side, and these go horizontally. These go vertically. Okay. Some of you might be aware of that. Some of you might not. So just in case. And this is the positive side. Okay, so again, horizontally, vertically. Okay, now I'm gonna add the resistor. Here. See, so it connects and it goes horizontally. I mean vertically. And this one's gonna be 1,000 kilo ohms. Now I'm gonna have to check the PowerPoint for what was the value for the second one. I kind of forgot. Let's see, 363 ohms, roughly 363. So I'm gonna add a second one. Yeah, I usually do this faster, but doing it real time is kind of rough. 336. Okay, so yeah, and this one goes here, and we're gonna have to measure it. Measure voltmeter, multimeter. Okay, so it goes in between the resistors. Oh, and this one has to be the lower value. Oh, shit. This one, they're higher value. Yep. It goes in between. So, positive. Negative. Let's see if that works. 336. Oh, but it's okay. So it works, but it is the other. Yeah, we just got a negative value because the positive is connected to the positive and the negative to the positive. So let's change that. Let's see, positive. Negative. And there we go, 3.36 volts. So we were aiming at 3.3. This is 3.36. Close enough. Close enough. Yeah, that's it. You know, and this is 4.5, and the output is 3.36. So that's how it works. I had to pause the video a little bit. Yeah, I've had a little bit of insomnia. I'm a little bit sluggish. So, anyways, yeah, we divide 336 by 2, we get 168. And so, yeah, I use two resistors in series. And yeah, we get the same result, 336. So, yeah, and say I wanted to well, no, I'm gonna leave it there. You get the idea. So that's it for now.